In this video I'm going to show you how to find the limits of a rational function, and there are several cases. We do different things to find limits at infinity and when x approaches to a value. Let's start with the first two problems where x approaches to infinity and negative infinity, and let's recall that the limit of a rational function in this case depends entirely on the leading terms of the polynomials in the numerator and the denominator. So this limit of this function at negative infinity and positive infinity will be exactly the same as if we just consider the leading terms of the polynomials involved. So if I ignore everything but 3x squared in the numerator, everything and but negative x squared in the denominator, then the limit will remain the same. And now we see that x squared can be reduced, so the answer is simply negative 3. The same is going to work when looking for the limit of a rational function at positive infinity. We can also ignore all but the leading terms for every polynomial, and we'll get exactly the same result. So the answer for the first two limits is negative 3. In terms of graphing, that means that this rational function will have a horizontal asymptote y equals negative 3. Now, how do we find the limit of a rational function as x approaches to a value? Well, then it depends on what that value is. So let's write out the limit. And when we're trying to find the limit of a function at a point, we always want to try and plug in that point into the function. So let's go ahead and plug in 2 into this function and see what happens. And what happens is that we get the 0 in the denominator, so that means the function is not continuous at this point. But we also get the 0 in the denominator, in the numerator. So that means we can possibly have a removable discontinuity. So when that's the case, we want to find that common factor that numerator and denominator have in common and reduce the expression that defines the rational function by that factor. Basically, we want to simplify this rational function. So we have to factor out the polynomials in the numerator and the denominator, and the factorization of the polynomial in the numerator is the following. We have 3x minus 1 plus 1 times x minus 2. So knowing that 2 makes it 0 helps us with the factoring of the polynomial. And the denominator we can factor by first taking out the negative and then factoring out the difference of squares. And now we see why we had 0 over 0 behavior. And that's what's left after we remove the common factors. So let's try and plug in 2 again. Well, this time nothing happens, nothing interesting happens, so we can simply state that the limit of this function as x approaches to 2 is negative 7/4. So what about the limit of this function at 0? So let's write this out. And to find the limit at a point, we always, like I said previously, want to try and plug in this value into the equation. So what happens when we replace x with 0? turns out that nothing interesting happens here. So we don't have any issues with this function at 0. So the answer is simply -1/2. So this is how we find the limits of a rational function. It really depends on where x is approaching to, whether it's infinity or a number, and it also depends on the what the function looks like. So working with rational functions takes a lot of focus and knowledge of the rational functions.